Bonjour, je vous présente aujourd'hui un outil de calcul distribué, Matlab Distributed Computing Toolbox. Cela entre bien dans le cadre de cours techniques modernes d'analyse des systèmes. Vous allez voir une démonstration faite par MathWorks. Cette démonstration simule comment quelques paramètres tels que la pluie affectent la performance d'un système de radar pour suivre la trajectoire des avions.
The distributed computing toolbox enables you to execute coarse-grained Matlab algorithms and Simulink models in a cluster of computers. This can substantially reduce overall execution time for many types of applications, including those in which algorithms or models are executed repeatedly on varying datasets. This demonstration shows how to use the toolbox to run a Simulink model repeatedly on remote worker sessions of Simulink, with each simulation using different model parameters. The model simulates how parameters such as rainfall affect the performance of an aircraft's radar tracking system. We will focus on how we run our simulations on the remote workers rather than focusing on the application itself. Let's open the model and give a high-level overview of its components. The model is organized into three subsystems: radar, aircraft, and weather. The overall goal is to simulate how radar and weather parameters affect radar tracking performance. The model includes a GUI for conveniently setting model parameters. It takes about 5.7 seconds to simulate this model, which means it would take about 4 minutes and 45 seconds if we were to run it 50 times. Using the distributed computing toolbox, we can run our model simultaneously on multiple workers, using different radar and weather parameters in each simulation. Depending on the number of workers we use, this can substantially speed up our overall task. Before we can distribute our model to our workers, we need to divide it into jobs and tasks. We'll create a single job that contains 50 tasks that each simulate the model using different radar and weather parameters. Let's take a closer look at the M file used to divide our application into jobs and tasks. We'll open this M file, which is called dct.atc.m. Our function begins setting up the distributed problem by finding a job manager called myJobManager. The job manager is responsible for coordinating the execution of tasks on the worker sessions. After we find the job manager named myJobManager, we create a job on it. We then specify the finished FCN job property, which specifies a function to execute when the job finishes. Our function simply calls the talk command, which lets us see how long it takes the application to run. We also specify the file dependencies job property, which indicates which files and directories the workers can access. In this case, we let the workers access the M file that we're currently looking at. After creating the job and specifying its properties, we begin creating tasks. We create a total of 50 tasks that each run our Simulink model using different radar and weather parameters. There are 10 different noise levels for the radar, each of which is simulated at 5 rainfall intensities. The function that each task executes is called SimUnit. This function sets the rainfall and radar simulation parameters of the model using the model initialization function callback, initFCN. The SimUnit function then runs the model using the sim command. After specifying that each task executes the SimUnit function with certain radar and rainfall parameters, we specify the finished FCN task property. Our task's finish function checks for errors during task execution, obtains the simulation results from each task, and plots them. After all the jobs and tasks are set up, we submit the job. Let's now set up our Matlab distributed computing engine so that our job manager and workers will run on the appropriate machines. For our application, we'll use 4 workers. We'll set up our client machine to act as a job manager and a worker, and we'll use 3 remote machines to serve as the other 3 workers. To set up a job manager on our machine, we need to open a command window, go to the Matlab root /toolbox/distcomp/bin/win32 directory and enter the command start job manager -name my job manager. Note that you need to have the activation service running on all machines that are used as job managers or workers. This is explained in the product documentation. We now have to associate each of our 4 workers with this job manager. We'll create one worker on our machine by entering the command start worker -job manager my job manager -name worker 1. The 3 additional workers are created in the same manner on remote machines. All workers must be associated with the job manager called my job manager that was just set up for our application. Now that our job manager and workers are set up, we will run our application by typing pct-atc at the Matlab command prompt. As the tasks are completed by the workers, the results are displayed via command in the finish function that we specified for each task. Our distributed application running on 4 worker machines takes only 1 minute and 48 seconds, while it would take almost 5 minutes on a single Simulink session. If we used more workers, we could have run our application even faster. As we have seen in this example, the distributed computing toolbox can significantly reduce the execution time for applications that simulate the same model repeatedly using different model parameters. This concludes our demonstration. You can close the window now or play this demonstration again by using the controls below.